Non-contact force examples. Clothes from dryer. You must have observed the static cling on clothes. This is because of the triboelectric effect, which comes under electrostatic force, and is type of non-contact force. Triboelectric effect causes the static charge on your dryer's clothing to become negative as various materials with varying affinities for electrons tumble together. This causes materials with a stronger affinity for electrons to lose electrons and become positively charged. For a period of time while the clothes are drying, the initially humid environment provides a relatively conductive electrical path for static electricity to dissipate. However, as the clothes dry and the relative humidity in the dryer drum falls to extremely low levels, the air in the drum becomes highly resistive, causing the static charges generated by the dryer's tumbling action to accumulate more quickly than they can be dispersed. Sugar in plastic jar. Sugar is the most prevalent component in every kitchen, and we all have a lot of it. If you look at the sugar that is kept in a plastic jar, and if that plastic jar is transparent, you may notice that the sugar has adhered to the inside of the plastic jar. This occurs as a result of the electrostatic force that is formed between the plastic jar and the sugar crystals. Here in the case, this electrostatic force is simply a non-contact force. Attraction of paper pieces on comb. This is one of the most straightforward but effective non-contact force examples. Aside from that, this is one of the most typical demonstrations used in schools to demonstrate how static electricity is produced. When we rub the comb or balloon on our hair, and then bring it close to the little bits of paper, we can see that the paper pieces are drawn to the comb or balloon and disappear. This demonstrates that a non-contact force, in the form of electrostatic force, is there. Solar system. We all are familiar with the words, solar system? The gravitational force of the sun draws the planet toward it, causing the straight line of direction to transform into a curved line. Consequently, the planet continues to move in an orbit around the sun. In our solar system, the sun's gravitational pull causes all of the planets to rotate around it. This force, so-called gravitational force, is a form of non-contact force that acts between the sun and the other planets of the solar system. Throwing ball. While playing on the ground with ball, we often throw the ball in order to pass it to another person. When we do so, then after reaching to certain height the ball falls back on the ground. The ball is falling to the ground as a result of the gravitational pull of the earth acting on the ball during its flight. This gravitational force between the ball and the ground is a type of non-contact force which pulls the ball in downward direction. Leaf fall. In the autumn season, we usually observe the falling of faded leaves. When the tree's leaves fall, they always falls on the ground or surface of the earth. This fall is simply because of the gravitational force, which is a type of non-contact force, acting between the leaves and the ground or surface of the earth. Earth's gravitational force always attracts the bodies towards it. Leaf fall is the best and common non-contact force example. Roller coaster ride. An amusement park is incomplete without the roller coaster ride. Roller coaster ride needs some applied force through the form of electrical motor to reach up to certain height. After reaching that height, roller coaster is set free to work on the gravitational force alone. This working of roller coaster with gravitational force is simply a non-contact force. A door catch. When it comes to kitchen cabinets or other types of cabinets and the doors, a magnetic catch is typically employed to keep the door closed. The working of door catch is efficient than the other traditional latches. Here, the working of magnetic force shows the type of non-contact force. Magnetic levitation trains. Magnetic levitation trains, also called as maglev trains, worked on the powerful electromagnets. The fundamental principles of magnetism are used to make these trains float over guideways, rather than the traditional steel wheel and track locomotives. Because there is no friction between the rails, these trains may run at speeds of hundreds of miles per hour or more. But speed isn't the only benefit of maglev trains. Because the trains hardly, if ever, touch the track, there is far less noise and vibration. Magnetic levitation trains. Maglev trains are less vulnerable to weather-related delays due to reduced vibration and friction. As a key contrast between them and conventional trains, magnetic levitation trains, maglev trains, do not have an engine, at least not the type used to accelerate standard train carriages over steel tracks. It functions only on the basis of magnetic force, which is a form of non-contact force. Attraction of iron pins. Iron is a magnetic material, and iron pins are created from it. Magnets are attracted to iron because of the impact of their magnetic field on the iron's magnetic properties. The iron pins stick to each other below the pole of a magnet because the magnet creates magnetism in the iron pins, which is attracted to the magnet and clings to it as a result of the magnetism. By magnetic induction, the magnetized pins magnetize and attract the other pins in the vicinity of the magnetized pins. Therefore, this magnetization and attraction of an iron pins becomes a non-contact force example. Navigation compass. You must have seen the navigation compass, which works on magnetism. The red pointer on a compass is actually a magnet, and it is being drawn to the Earth's natural magnetism, which is referred to as the geomagnetic field. The Earth operates like a huge bar magnet, with one pole located in the Arctic, near the North Pole, and another located in Antarctica, near the South Pole. For example, if the needle in your magnetic compass is pointed north, this indicates that it is being pulled, attracted, toward anything near the Earth's North Pole. Since opposite poles attract, your compass must be drawn to a magnetic South Pole. That is, the magnetic North Pole of Earth is really the magnet's South Pole. So this becomes one of the good non-contact force example. Raindrops falling on the ground. We all enjoy the rainy season. Because of the force of gravity, raindrops and all other falling items are pulled to the surface of the Earth. This action of gravity is simply a type of non-contact force. However, the procedure that raindrops travel through in order to arrive at the place where they fall is a little more complex than a basic gravitational impact alone. In order to produce rain, water must first become a gas, rise into the atmosphere, and then return to a liquid state again. The droplets subsequently yield to gravity and fall from the clouds. The hydrologic cycle is the collective term for the process through which water turns into rain and falls. Frequently asked questions (FAQs). Q. What do you mean by non-contact force? ANS, non-contact means no physical contact. The force that a body may exert on another body without ever coming into physical contact with it is referred to as non-contact force. Q. What are the different types of non-contact force? ANS, there are 4 types of non-contact force as follow. Electrostatic force, gravitational force, magnetic force, nuclear force. Electrostatic force. Electrostatic force is the force that arises between two charged objects when they come into contact. Everything is composed of microscopic positive, negative, and neutral particles. Opposite charges attract one another and similar charges repel one another. This is the consequence of electrostatic forces acting on the particles. Gravitational force. There is a gravitational pull between all objects that have mass in them. It is a universal force that pulls items in the direction of one another. Everything is drawn toward the center of the Earth by the gravitational attraction of the Earth's gravity. Magnetic force. When two magnetic fields come into contact with each other, they create magnetic force. Magnetic forces can be either pull, attraction, or push, repulsion, forces, depending on the type of moving charge on a metal object. Nuclear force. Nuclear force is classified into 2 types: strong nuclear force and weak nuclear force. In a nucleus, there is a short distance force called the strong nuclear force, which occurs between basic particles. It is not affected by charge and may be used between protons and protons, neutrons and neutrons, and protons and neutrons, among other situations. When a neutron decay takes place, the weak nuclear force is responsible for mediating the process, which results in the production of a charged particle and an uncharged particle known as a neutrino. Q. State the difference between contact force and non-contact force. ANS. The following table illustrates the difference between contact force and non-contact force. Contact force, non-contact force. This force is only produced when two separate things come into touch with one another. If there is no contact between the two items, then a non-contact force is produced by either attraction or repulsion between the two things. The field and the contact force have no connection or physical contact to one another. The presence of non-contact force is usually accompanied by the presence of different types of the field. Contact forces are classified into the following categories: applied force, spring force, normal force, air resistance force, frictional force, and buoyance force. Other than contact force, there are other sorts of non-contact forces. These include electrostatic force, gravitational force, magnetic force, and nuclear force. The contact force examples are glass of water on the table, hovering mouse, bungee jumping, suspension bridge, airplane in the sky, wooden block floating in water, sliding in playground, jar opening, etc. Non-contact force examples are throwing a ball, solar system, attraction of iron pins, attraction of paper pieces to hair comb, leaf fall, magnetic levitation train, roller coaster ride. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.